In this tutorial, we are going to learn how to brute force attack a Caesar cipher in order to reveal a hidden secret message. This is exercise 2 Caesar cipher cracker in the Introduction to Ciphers lessons. So you can see here I have my instructions using Python code to break a Caesar cipher. I have my main.py, which has some code which I'll go through in just a moment. And there are a few rules to using this code. So the supplied code can break a message as long as we follow these rules. 1. You can change the ciphertext, but it must be inside 3 sets of speech marks. So this message here, LQ and so on down to BRX, you can replace that with a different Caesar message. And in actual fact, I have used a different message to the one that you've been supplied. So I have a different message here to what you have. You can put a different message in here as long as it goes between 3 quotes at the start and 3 quotes at the end. Next, don't change any of the code or you may break the program. So there's lines of code like print decoded or for letter in ciphertext. Don't change those. You're only going to change this line here. And you will need to shift the Caesar string to try out different versions until you brute force the answer. Brute force means trying every possibility until you get what you're looking for. So what we're going to do is we're going to start off with a Caesar cipher. We're going to run the code and see what we get. And we're then going to adjust the alphabet until we get the correct combination that reveals the message. I'm just going to put away the files here so I've got a bit more space to work with, and I'm going to click on run. And you can see that what's happened is I've got a gibberish message has appeared. Doesn't make any sense, although it is different from the original ciphertext. So this one started LQ and ended BRX. This one starts KP and ends AQW. Let's have a look at what's going on here that we're using to break the Caesar code. I've declared the alphabet is just A to Z, and I've also put some extra punctuation on the end, things like a space and full stops and so on, in case they're needed. This /n here is the new line character. It's like pressing enter on your keyboard, and that might sometimes show up in some of your messages if it's split into paragraphs. I've then got the Caesar cipher. Now the Caesar cipher is the letters B through to Z and then back to A again. So I've basically shifted the whole alphabet by one place. I took the letter A off the start of the alphabet and I put it onto the end. Notice that there's 26 letters here and there's 26 letters here. If they don't match up exactly, your code will probably have problems. Here is the ciphertext. It's a message that's contained within 3 speech marks at each end. So it's a box called ciphertext that's got information in it. I've also declared another box here at line 8 called decoded, and decoded is an empty string. It's just basically a box that's got nothing in it to start with. But what we're going to do is for letter in ciphertext. So I'm looping through every letter in the ciphertext. I start with the letter L. I deal with that, then I move on to the letter Q. I deal with that, and then I move on to the space that's there. I deal with that, and then I move on to the letter I. So I'm going to work through one letter at a time, one character at a time, decoding this message. So how do I decode it? Notice this code has got 2 lines inside the for loop. So each of these 2 lines is what will be repeated. How do I know that? I know that because the colon starts here on line 9, and then I've got indented line 10, indented line 11, therefore both of these things will be repeated for each letter. What am I going to repeat? I'm going to get a position by looking at the Caesar alphabet and finding the position of the letter. So if I take the letter L, I go and find it in Caesar, which is L, and I look at what's above it in the alphabet, which is K. And that's where this K here has come from. So this K of KP is a translation of L from the ciphertext into a decoded message. I add on to decoded. Remember, decoded started as an empty box, but I add on whatever's at the same position in the alphabet. Then I move on to Q. So I loop through using my for loop. I find Q in the Caesar code, it's here, and I go up above it and I find P, and that's where the P of KP has appeared from. So I'm going to go through every single letter and piece of punctuation, replacing the Caesar equivalent with something that's in the alphabet. And when I'm finished all of that, and I've got to the very last letter of BRX, so I get to the X, I'm finished, I drop out of the for loop, and then I print the decoded message. So that explains where this has come from, but obviously it's not a decode of a Caesar cipher. So what do we have to do? Well, we basically go through all the possibilities. I've got one that starts with B, it's gibberish. I take the B here, off of the front, and I add it on to the end. And I gotta make sure that, I've got caps lock on, I make sure that there's 26 letters here, 26 letters here. I run it again. I get this, it's still gibberish. So I go back, I take the C off the start of the alphabet, I add it to the end of the Caesar, and I run. And what I've got here is, in future exercises, you will need to read the instructions as there will be no videos to guide you. So I have got something that makes some sense if I start my alphabet at the letter D. So Caesar code there starts at D, and that turns this into a decoded message. You will have to go through a similar process with the message you've been supplied with, constantly taking a letter off the start of the alphabet and then moving it to the end. Dragging doesn't work particularly well in Replit, so you're probably going to have to delete from there and then type at the end of the letters here. Work your way through, even if you have to go all the way to starting with Z. At some point you should find that you have got a sensible message in terms of breaking the code. So good luck with that, and we will move on to more complex ciphers in future.